Hello all and welcome to this series of interaction on triangles class 10th. In this video we'll take up and finish this exercise 6.2, right? So let's begin from the question number 6. We are given a triangle PQR and a point O in the interior of triangle such that by joining O to PQ and R there are points A, B, and C on OP, OQ, and OR such that AB is parallel to PQ and this AC is parallel to PR. We have to show that or prove that BC is parallel to QR. Okay, so let's proceed by, we'll do this question by BPT. This is basic proportionality theorem. So in this triangle POQ, in this triangle AB is parallel to PQ, right? So by BPT, basic proportionality theorem, this OA upon AP is equal to OB upon BQ, right? Similarly, in this triangle POR, same BPT, we can write that OA upon AP is equal to OC upon CR and mark this as equation 2. From these two equations, we see that the left hand side is equal to, means OA upon AP is equal to OB upon BQ as well as OC upon CR, which implies or which gives us that this OB upon BQ is equal to OC upon CR. Now see, in this triangle OQR, OB upon BQ is equal to OC upon CR, means this BC is dividing these two sides in equal ratio. So this must be parallel to this third side QR by the converse of a BPT. So we can write this by converse of BPT. BC is parallel to QR in triangle OQR. This is what we needed to show or we needed to prove. So let's take the second question. In question number 7, prove that a line drawn through the midpoint of one side of a triangle parallel to the another side bisects the third side. So here we are given a triangle ABC and let D is the midpoint of AB. If we draw a line parallel to BC from D, it will bisect AC. This we need to prove. So let this DE is the line parallel to BC from point D. Okay, now let's prove it. Since D is the midpoint of AB, midpoint means it divides AB into two equal parts. AD is equal to DV. Let it be X. Also DE is parallel to BC, that is given to us. So by basic proportionality theorem, in this triangle AD upon DB is equal to AE upon EC, since D is parallel to BC. Means AD upon DB, AD and DB both are taken as X, so X upon X is equal to AE upon EC. Further, this is 1 is equal to AE upon EC, or EC is equal to AE. Simple simplification of this equation, right? Means EC is equal to AE. So this E is also the midpoint of AC, as it is dividing this AC into equal parts. So E is the midpoint of AC. In other words, we can say that DE bisects the AC, bisects the third side, which was asked in the question. Okay, so next question. Okay, so question number 8, using the converse of BPT, we need to prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side, right? So let's take ABC is the triangle, and D and E are the midpoints of sides AB and AC respectively. So line joining this D and E is parallel to third side, that is BC, we need to prove, right? So since D and E are the midpoints of AC and AD and AC respectively, means this divides AB into two parts, AD and DB, let the length is of both the parts is equal to x. Similarly, length of AE and EC is equal to y. Now AD upon DB is equal to x upon x, that is equal to 1. Also AE upon EC is equal to y upon y, that is equal to 1. So from these two equations we saw that both the ratios are same. AD upon DB and AE upon EC is same. Means in triangle ABC, DE is dividing these two sides in equal ratio, right? In same ratio. So by the converse of VPT, we can write that DE is parallel to BC, right? If a line divides the two sides of a triangle in same ratio, it is parallel to the third side. This is the converse of the BPT, right? So by the converse of BPT, we can write that DE is parallel to BC. This is what was asked in the question. Okay. Take next question. So in question number 9, ABCD trapezium in which AB is parallel to DC and diagonals intersect each other at point O, show that AO upon BO is equal to CO upon DO. So this is a trapezium. Trapezium, we know, a quadrilateral with a pair of opposite sides parallel. That is trapezium. So in this, AB is parallel to DC. Two diagonals AC, BD, they intersect at O. We need to show that AO upon BO is equal to CO upon DO, right? So for this, we need a construction OE parallel to DC. We draw a line parallel through OE to DC, parallel to DC. So now, since AB and DC are parallel, this is given that trapezium means AB and DC are parallel. This is parallel to this side, DC, by construction. So this will also be parallel to AB. Clear? Line parallel to one line which is parallel to another line means that line will also be parallel to that another line. So OE is also parallel to OB, AB. So now in triangle ABC, OE is parallel to AB. So by BPT, we can write that AO upon CO is equal to BE upon CE. Right? Similarly, in triangle BDC, since this is parallel to this, so BO upon DO is equal to BE upon CE. This is equation number 2. So again, from 1 and 2, we see that BEC is same in right hand side in both the equations. Means BE upon CE is equal to AO upon CO, as well as the ratio BO to DO. Means this is same equal to this, so these two ratios are also equal. So from 1 and 2, we can write that AO upon CO is equal to BO upon DO. So what we need to prove is AO upon BO. So BO need to be here. We simply transpose this CO and BO. CO when transposed to this side, it will be multiplied in numerator. BO when transposed to this side, it will go to the denominator, and we get the final result, that is AO upon BO is equal to CO upon DO. Hence it is proved, or what was asked in the question. Okay, so let's take the last question, that is 10th. In 10th question, the diagonals of a quadrilateral ABC intersect each other at the point O such that AO upon BO is equal to CO upon DO. Just show that ABC is trapezium. So it is just the converse of the last question, that is 9th question. So this is a quadrilateral ABCD. There are two diagonals intersected O. So we'll first construct OE parallel to DC, right? Then In triangle, this A, D, and C triangle. A, D, and C triangle. Since this is parallel to this, so this upon this ratio will be same. Means AO upon CO is equal to AE upon DE. This is equation number 1. Also, we are given that AO upon BO is equal to CO upon DO, which means by transposing in this given relation, we transpose BO and CO. What we get? We get AO upon CO is equal to BO upon DO. This is equation number 2. Let okay. So now see, from 1 and 2, AO upon CO, AO upon CO, right? AO upon CO is equal to AE upon DE as well as BO upon DO. So from 1 and 2, we get that AE upon AE upon DE is equal to BO upon DO. So now in this triangle, this segment, this line divides the two sides in the same ratio. Means it's by the converse of BPT, this should be parallel to AB, right? OE divides the side of AB and DB in same ratio. By converse of BPT, OE is parallel to AB. But by construction, we draw this OE parallel to DC. Now, OE is also parallel to AB. So, OE is parallel to DC and OE is parallel to AB as well, which means that this AB and DC are also parallel. So this proves our questions. Means in this quadrilateral we get a pair of opposite sides parallel. AB is parallel to DC, so this is a trapezium, right? Hence ABC is trapezium with AB parallel to DC. So this concludes our exercise 6.2 based on basic proportionality theorem. Next in the line is the criteria for similarity and questions based on similarity criteria, right? So we'll use this basic proportionality theorem to verify or prove the criteria first, then do the questions, right? So just practice this BPT and go through once again the proof of BPT, how this theorem is proved, and how the converse is applied in the questions. Okay, and till then, as usual, keep drilling and keep practicing. Okay, you are what you believe yourself to be. So believe that you can achieve the goals. Thank you. Thanks for watching.